Welcome to another exciting adventure of Mr. Warnow Does Your Homework. Alright, today we are looking at applications of chain rule with related rates. So this is a really good application problem for us in terms of how chain rule can work. We have a bee that is buzzing around a room. The position of the bee is given by this position vector. Vectors. And they tell us the temperature at any location of the room is given by the product x, y, z. So we know that the temperature is a function of x, y, and z. It's a three-dimensional because the bee is somewhere in the air. So is x, y, z. Time is measured in seconds, distance in feet. Now, the first question they're telling me is to find the rate of change of the temperature in terms of t using the chain rule at any point along the bee's path. Now remember, the path is this parametric equation right here. Now we should remember that this is a spiral or our helix. So what we're asked to find is the temperature, the change in temperature with respect to time. Now there are two ways we can do this. One, we can substitute the x values and the y values and the z values in. Remember, if this is my parametric, right, they're really saying x is cosine of t, y is sine of t, and of course z is 1. So one way I could do is I can just plug those in, get cosine t, sine t, times t. Whoop, there shouldn't be 1, there should be a t there. T. And this is not a very easy derivative necessarily to take, so I'm not going to worry about this one. We're going to use our chain rule that we learned, because if anything else, it's chain rule. We should know how to do this one anyways. So let's see here. So we're going to take the derivative when we do our chain rule. The first variable we come across with is x. So we take the derivative of x, of our temperature function with respect to x. But now we got to do the inside, because remember, x is being substituted with cosine of t. So we're going to take now the derivative of x with respect to t. And I keep going the same thing with the y's. The partial of temperature with respect to y. And remember, y is sine of t, so we have to take that's derivative 2, the partial of y with respect to t. And I keep going to do the same thing with the z's. Partial of t with respect to z, dz, dt, or del z, del t. That should be a z, yeah, del z, del t. Sorry about that. So let's go ahead and do this. When we find our derivatives, well, the derivative of temperature with respect to x, well, that's just going to become y times z multiplied by the derivative of x with respect to t. Well, x is cosine of t, so we know that's negative sine of t, plus the derivative of t with respect to y, well, that's just xz. The derivative of y with respect to t is cosine of t, plus the derivative of temperature with respect to z becomes xy times the derivative of z with respect to t, which is just 1. And you can leave it like this, or you can write this as a parametric. If I substitute in, for instance, I know y is sine of t, z is t. Well, I already know this sine t here, so I can write this as negative t squared sine of t, plus here, x is cosine times this cosine. So I know I'm going to get cosine squared of t times z, which is t, plus here the x times y, cosine t times sine of t. And here we wrote it as a parametric formula, as a parametric. Now remember, this is one independent variable, and that is t, right there. Now the next question, we're going to start to apply a little bit of this, okay? It says, find the rate of change, again, looking for the derivative of the temperature after the bee starts at the point 1, 0, 0 and travels a distance of 4 root 2. So what do we need? We want to find the rate of change of the temperature after the bee starts. So what we need to find is the time. We don't know where the bee is. So we want to find when the bee has traveled this far, we want to find that rate of temperature. So what we need is time. How long does it take the bee to travel that far. So to get time, we're going to use our distance formula. We know where it starts, and we can find the distance. So our distance formula is going to go from 0 to t. We start at t equals 0, that's right here, and we find how far it travels. Now remember, this is going to be the magnitude, right, of x prime of t squared plus y prime of t squared plus z prime of t squared. And we know that this distance has to equal 4 root 2. So when I integrate this one, well, we got 0 to t. Well, let's find our derivatives. X of t is cosine, so when we square that, of course, we're going to get negative sine squared, or negative sine of t, so we square that. Sine squared t. This becomes plus cosine squared of t, plus, and derivative of t is 1. Square that, we get 1 dt, and that's going to become 4 root 2. Simplifying here, right, this is 0 to t. Well, that's just 1. 1 plus 1 is 2 dt. And therefore, we're going to get, if we integrate this, we're going to get root 2 t equals 4 root 2, and therefore t is just 4. So we're saying here that the bee traveled for 4 seconds, right here. Now that I know how far now that I know how long it took the bee to travel, now I can actually calculate the rate of change of temperature with respect to time. See, that's why you had to find time. So now I can find my partial t with respect to time, and I can plug this into our values right over here. Well, this becomes negative 4 squared times the sine of 4 plus the, that should be sine squared, sorry about that, sine squared of 4 plus cosine squared of 4 plus sine 4 cosine 4. And there's our rate of change. Now remember, this should be sine squared. I think I said that, I just didn't put my square. Because remember, y is sine. If I multiply by this sign, we get sine squared. And if we simplify this, be careful. That is not positive 16. That is negative 16. Okay? So be careful with that. Times, well, we won't do it that way. So, and when we type this all in our calculator, what we wind up with is negative 0.087 degrees. We're talking about Fahrenheit per second. And that's the rate of change of temperature after the bee has traveled to a distance of 4.2 units. All right. So I hope you enjoyed this video. Go to the next video. We'll take a look at part C.